Okay, let's go to page 110, and this is lesson 8.5, and this lesson is on asymptotes. Okay, so we just kind of covered a little bit in the previous lessons about asymptotes. So again, if you have a f of x equal to 3x squared minus 6x plus 3 over 5x squared minus 25x plus 20. So if you were to, okay, so first right away, if you're going to look for the limit, so the limit of f of x as x approach infinity, right away you can see that all is going to be gone, and the x squared will cancel out, so equal to 3 over 5, which is also the horizontal asymptote, by the way. Okay, so okay, so now to graph this, you have to get all those information. So there are several forms that you need. Okay, so first is, let's go and factor these. Okay, so let's go up to the side. So 3x squared minus 6x plus 3. First you can factor the 3. And then you're going to get 3. You're going to have x minus 1 squared. I'm going to write it out 2 times because I have a feeling we're going to cancel things out. Okay, on the bottom, you got 5x squared minus 25x plus 20. So go and factor the 5. So you get x squared minus 5x plus 4. Okay, and then you're going to get x minus 4, x minus 1. So you're going to get 5 over x minus 4, x minus 1. Okay, before we do anything, before we do any cancellation, remember x cannot equal to 4, x cannot equal to 1. Okay, so but just from the experience, we know that this is going to be the vertical asymptote. This is going to be an open circle on the graph. Okay. Okay, so again, so you're going to get f of x equal to 3 times x minus 1 over 5 times x minus 4. Okay. Okay, so again, let's get all our information. So vertical asymptote. Okay, so vertical asymptote would be x equal to 4. And because when you divide, you're going to, okay, let's go and divide. Okay. You don't have to divide because it's so obvious, but I'm going to just divide so you can see. Okay, so again, you always want to make the first term match. So you're going to times it by 3 over 5. Okay, so this will give you 3x squared minus 15x plus 12. Okay, and again, this will cancel out. So it'd be 9x minus 9. Double check. Yeah. Okay. So f of x is going to be equal to 3 over 5 plus 9x minus 9 over 5x squared minus 25x plus 20. Okay. So you're going to get horizontal asymptote. Again, remember this part is your asymptote. Okay, and this whole part is your graph. Okay, that's your entire function. So your graph is equal to asymptote plus something. Okay. Anyway, okay. So again, you're going to get horizontal asymptote. It's going to be y equal to 3 over 5. Okay. Then you're going to set. You're going to find the x-intercept. Sometimes it's easy to find, sometimes it's difficult. So again, x-intercept is when y equal to 0. So so you probably want to use, okay, so let's say if you use this one over here, okay. So again, remember you set y equal to 0, you cross multiply, you're still going to get 0. So basically you're setting the top equal to 0. So from here you're going to see x equal to 1. Okay, so that's going to be your intercept, but it's also going to be the open circle because they're not equal, right? So just be aware of that. and then you're going to get y-intercept. Okay, y-intercept is when x equal to 0, right? So when x equal to 0, when x equal to 0, what does y equal to? Well, yeah, this is a bit easier, right? When you set x equal to 0, all this will be gone, so be y will equal to 3/20. Okay, so use this one. So again, each form has advantage for certain things. Okay, so again, y-intercept is when x equal to 0, so it'd be easy if you use this one, because all this would be 0, 0, 0, so it'd be 3/20. Okay, that would be the easiest one. Okay, so now you have all this information. Now you're going to do the graphing, okay, or sketching. Okay. Okay. So first you go and get all your asymptotes. Okay. So vertical asymptote when x equal to 4. Okay, so that's your vertical asymptote. And the next one, horizontal asymptote, is 3/5. Three over 5 is 0.6, so it's right over here. Okay, and now your intercept. So x equal to 1. It's an intercept, but remember it's not allowed, so therefore it's an open circle right over here, but the graph will go through that. And the y-intercept is 3/20. 3/20, so 0.15, so it's going to be right over here. Okay. Okay, so with this information, now you're ready to graph, right? So again, from here you can see that since there are 2 points, so and that's an asymptote, so you know the graphs are going to go like this. Okay, and it's going to go like this. Okay. So again, how do you know the graph did not go like this? How do you know that? Well, in this case, actually, it's very easy. Okay, you don't even have to do this test. Okay. The reason for that is because notice, well, in this case, actually, it doesn't go over, but we know it's not going to be like that. But how do we know that this does not go up later on, like right over here and rise and go over? Okay. The reason we know it's not going to go up because there's only one y-intercept. So it cannot go on above because it has to go through that point. Okay? Now, again, if you look at the graph, so over here, x is negative, right? So over here, x is negative. So when you look over here, when x equal to negative, okay, when x equal to negative, this is going to be still positive. But when x equal to negative, this is going to be negative. So the graph is going to be asymptote minus something, right? Because this is negative. Okay, so graph is asymptote minus something. So graph is going to be below the asymptote. Okay, so that's how you know it stays below. Okay, so that's how you know it's like that. Okay, now whenever there's a vertical asymptote, it will go opposite direction. So this graph is going to go like this. Okay, oh, be careful not to touch that. Okay. But again, how you know if it goes like this or like this, stay above or below. Again, if you look over here, x is positive, so everything's all positive, so the graph is going to be asymptote plus something. So again, because x is positive, right? So everything's going to be positive. So therefore, the graph is going to be above the asymptote. So it'd be that case. Okay? So that's how you know if it's going to be above or below. Okay? Most of the time, you don't have to check. Most of the time, it's pretty obvious. But in some rare cases, it will cross over and come back and stay on the bottom. So it's always safe to be, to check. Okay, so you can double check, make sure. Okay, so vertical asymptote, and there's a hole right over here. And so that is your graph. Okay. Okay, let's go to example 8-7. Okay, so you have this function f of x equal to 2x cubed minus 3x squared plus x minus 6. Okay? And then you have over x squared minus 3x plus 2. So again, first you want to see if you can factor as much as you can. So go and factor the bottom first, because usually it will give you a clue. So this would be x minus 2, x minus 1. Okay? So right away, x cannot equal to 2, x cannot equal to 1. Okay? Okay, so now over here, when you're doing the factoring, right, you can, so what you can do is, again, usually the bottom will give you a clue. So if you try synthetic division, okay, so you got 2, negative 3, 1, negative 6, right? So since this is one of them, let's try negative 2, and let's try this factor. So again, you have to take the opposite. Okay, so you drop, multiply, you add, multiply, you add, multiply, you add. So yes, so this can factor that. So you're going to get x minus 2, and when you factor, you're going to get 2x squared plus x minus 3. Okay? And plus 3. Okay? And if you try to factor these, it's not going to work anymore. So that's it. Okay? Okay. So again, from here, let's go and get all the information. Okay? So vertical asymptote is going to be, oh, this will cancel out. So vertical asymptote would be x equal to 1. Now the next part, because the top is, the degree on the top is bigger than the bottom, so you're not going to get the horizontal asymptote. What you're going to get is a slant asymptote. Okay? And the way to do that is use the long division. Okay? So you can either divide this by this, or you can use this divided by this. It will come out the same. Okay, so it's easy if you probably use this. You probably divide by this one here. Okay, so 2x squared plus x plus 3 divided by x minus 1. So this would be 2x. So it would be 2x squared minus 2x. Okay, subtract. So it would be 3x plus 3, and then this would be plus 3. So it would be 3x minus 3, and this will give you 6. So f of x, when you divide it, actually it's going to become 2x plus 3 plus 6 over x minus 1. Okay? Okay, so from here again, this is your asymptote. And it's slant because it's not going to be horizontal because it's a variable, right? This is a linear equation, it's going to be like that. Okay, so slant asymptote would be y equal to 2x plus 3. Okay, and then again you get your asymptote, get your intercept. So x-intercept would be y equal to 0, right? Okay, so which one are we going to use? Okay, so let's go and use this one here. So it's set this equal to 0, cross multiply, so set that equal to 0. Okay, now this one, the x-intercept, in this case, if you solve, it's too complicated, then you don't worry about it. Most likely, because all these are positive, means you're not going to get the, there's no solution, no real roots. That means it does not touch the x-axis. Okay, so you don't have, and you're going to get y-intercept is when x equal to 0. Again, the way to do that is use this one here. So x equal to 0, all this will be gone. So you're going to get y equal to negative 3. Okay. Okay. So now we're to sketch these. Okay. Okay, this graph is going to be really big. Okay, so I'm going to make a scale a little bit smaller. Okay, so first, vertical asymptote x equal to 1. So that's this one here. And slant asymptote is y. So slant asymptote is y equal to 2x plus 3. So intercept is going to be at 3. Okay, so again, remember now, this is the actual intercept, but this is to graph the asymptote. So this equation is going to be at 1, 2, 3, and it's going to go up to go over 1. So it's going to be like this. Wait. Yeah. You have to be careful in the book. The graph looks really weird because they scale this into 10 times as that. So over here is 1, but over here is 10. That's why the graph looks really compressed. Okay. But anyway, so this graph more like this. Okay, so that is your slant asymptote, and there's no graph over here. And then y equal to -3 is one of the point. Okay. And x equal to 2, there's a hole at x equal to 2. Anyway, so your graph is going to look something like this, and it's going to be like this. Okay. And over here, again, you're going to, right over here, there's going to be a hole. So this one you kind of just estimate, so, and that's graph, that's going to be a hole right over here, open circle. Okay, so it's going to look something like that. Okay. So again, when you have a vertical asymptote, they will go opposite direction of each other. Okay, so if this goes down, this will go up. Okay. If there's a double vertical asymptote, let's say if this is like a square, it will be a double. If this is a square, it will be double asymptote. For the double asymptote, the graph will go in the same direction, either go like this or go like this. But if it's single, or actually it's the odd power, if the exponent is odd, they will go opposite direction. If the exponent is even, okay, like 2, 4, 6, whatever, then the graph, if you have vertical asymptote, it will go, it will go like this. Okay. So if it go in the same direction, if this is even, but odd, they will go opposite direction. So again, there's more detailed lessons in analytic geometry. Okay, so when you're doing the graphing, again, you got to get all this information. This will give you information to sketch out all the important feature of the graph. Okay, and you're able to kind of use those information able to graph.